So do you guys recall all this business? When it came to the sine of x, it's got a power series. I derived one of these, I can't remember which. I chose whichever one the author did not derive. So I may have them backwards. I might have derived sine, he did cosine, or vice versa. But sine of x has this as a power series. Will you know it off the top of your heads?
X.
Will you know it off the top of your head next week? Yeah.
One.
So you said x.
X minus 1 over 2 or 3 factorial plus, or x cubed. Why don't you just combine fractions there?
What do you mean by that?
Put the x cubed on the top.
Oh, that's fine. Yeah, I don't care which way you write them.
So-
Either way is fine.
I know how to derive this, but are we really just supposed to memorize this, or?
I think when it comes to sines,
Yeah.
cosines, and exponentials, you really should know this just like I am.
1
Okay.
over 5 factorial x to the 5th
So you get the pattern, right?
minus
Brad, can I come back?
Yeah.
I'm not saying that because, oh, I think you should. I'm saying that because when it comes to finding power series solutions to certain kinds of equations, you want to be able to recognize that as a pattern in there and rewrite it in terms of sine function.
Okay.
1 minus 1 over 2 factorial x squared plus 1 over 4 factorial x to the 4th.
Got it. I like it.
1 plus x squared
How about x?
x plus x squared over 2 factorial
Yes.
plus x to the 4th and 4
How
factorial.
about x3?
Or x, yeah, x.
Okay, I think we're seeing it. You guys there? Yes.
Now, the point to know these off the top of your head is to manipulate anything that you see that's close to it to make it look like it, or what is the point of?
Maybe the summer session, that's the point. But I think in the long run, is that if you come up with these power series in some other context, I want you to be able to recognize that you've got one of these basic functions. And yes, the inputs might be messed up.
All these are centered at 0?
These are, yes, because it's convenient. And if this were an x of 6, x to the 10th, then what changes over here? Well, this is an x squared. What
Yeah.
changes over here?
X squared sine
Yeah, it's just a sine of x squared.
or sine of x. If that was x squared, you would just be multiplying by x, right? Both sides.
Well, no, I'm saying if this were x to the 10th, and this were x to the 6th, and that were x squared, then I think it's a substitution. I think that x would be x squared, right? So it could be in a different form, couldn't it? I got an idea. Can I play with something completely new?
Why wouldn't you then square the factorials?
Because they're merely coefficients. And I think when you look at the power series the way I defined it, it makes no difference whatsoever. The coefficients are not going to change. But you guys, if you can allow me to do, somebody's really playing with these pens. Benji, I really just, boy. How about Christmas colors? And how about a better black pen? I like it. Can I get rid of this? You guys, I'm going to raise e to the Let's do something really interesting. Let's expand this out. So give me
Cosine, or 1 plus
1 plus
sine,
1.
sine of x plus, or cosine of x plus I sine of x.
Why? How'd you get that?
It's because that's the definition of sine of x in terms of.
I think better than saying definition, I think we can prove it. I think we prove it in terms of power series.
Yes.
Because I think raising e to any power is merely taking the third line in the middle board and simply replacing x with whatever the heck that power is. So here I go. I'm going to rewrite this as 1 plus, what's the next term? Is just x? The next term is 1 over 2 factorial x squared plus 1 over 3 factorial, I said 1 over 3 factorial x cubed plus 1 over 4 factorial x to the 4th. Oh no, you guys, I don't like this. I think raising I to those various different powers looks awful. So can I change it? I think what's sitting in front of me is the following. I've got nothing more than 1 plus x plus 1 over 2 factorial x squared, which I meant to write in red, jeepers, plus, set in green, 1 over 3 factorial x cubed, and I guess I'll just write down one more time. That's a plus 1 over 4 factorial x to the 4th. You guys there? I asked. Are you guys there?
So what happened to them?
It has to do with.
Oh shoot, it disappeared. I'll put it back in. So I was saying I messed up the i's, I'll put it in here. But if you don't mind, I think another name for I squared in the next term is
Negative 1.
negative 1. I'll put it in here. I think another name for I cubed is,
Negative 1.
say it again,
Negative 1.
negative, negative I. I think another name for I to the 4th is,
Negative 1.
very nice. And I know you guys are missing a lot of terms, usually many, but I hope you've seen the pattern. Because I think now, if I recolocate all the red terms, I get this.
So is it always just assumed that little I is referring to imaginaries?
Square root of
I hate to say always, it could be an index variable for a sum. I just meant it to be representing
Okay.
the imaginary unit in this example. Maybe I should have said that.
So on like a test or something, you'd clarify?
I don't think I would here because clearly it's not an index variable because I is not ranging from 1 to n
Okay.
or 1 to infinity. I just think in context it's clear in this example.
Okay.
And, oh no, I missed something, you guys. Hold it, I'll come back. I guess I've got plus inside my set of parentheses. Is that green stuff? How happy are you? I asked, how happy are you?
Well, isn't I raised to the 5th negative
Okay, you're not very happy because I think in black I missed an I factor here, an I factor there. I'll pull it out. But I think in the end, what I have, if you look carefully, what's written in red is nothing more than the cosine of my input x plus I times with what you see in green, jeepers, isn't that just simply the sine of x? Shoot, you guys, this is so important. Can I give it a name? I'll refer to this as Euler's identity. In Euler's identity, I've just proven with power series, that whenever it comes to e to the I theta, it's nothing more than the cosine of theta plus I times the sine of theta. So, Randall, are you the only person whom I know from trigonometry?
I think so.
Maybe? In trigonometry, remember for complex numbers? I said, when it comes to complex numbers, we can just think of them this way. Because that was a form of complex number in rule
Yeah,
form.
true.
And I used the e notation. I finally justified it.
Yes. Very nice.
You guys want to see something really slick? Check this out. Replace theta with
Pi.
negative 1. Oh, sorry, I misspoke. Thank you, Randall. I meant pi. Jeepers. I'm going ahead of myself. When you plug pi in for theta, what can you say about the sine of it?
0.
What about the cosine of it?
1.
That's slick.
Negative 1.
Think about it. Composing these three very interesting, most important numbers, but certainly non-rational numbers, not even non-real numbers together, those three of them, combined in this fashion, simply gives me something as simplistic as negative 1. That's pretty slick stuff.
Or if it's 2 pi, it's just 1.
That's true too. I agree.
Aren't you supposed to write e to the I pi plus 1 equals 0, and then you get all the major numbers together?
Say that again, Linda. I'm sorry.
Add
I
1
missed
to
it.
both sides.
What was that?
Add 1.
Like that.
Yeah.
To get this.
Yes. That's much better.
Equals 0.
Do you really like that better?
Yes.
Okay.
Now we have 0, 1, e,
Oh, I see your point, I see your point. So it makes this even prettier because it involves even one more special number of outcomes. I suppose, I suppose. Anybody else? All right. You guys, I forgot. How did I define the hyperbolic cosine of x? Hyperbolic cosine of x was, well, that's the inverse. Hyperbolic cosine of x was e to the x plus
e to the
e to the negative x all over 2. In other words, hyperbolics are defined in terms of exponentials, but they're related to circular functions. There's a very interesting relationship here, because I think when the input here is maybe a complex, then maybe we can reinterpret in terms of our circular functions. In other words, if you jump into higher dimensional space, there is a beautiful intimate relationship between the hyperbolic functions and the circular ones. You just have to switch positions of imaginary and real components. Really cool stuff. Take one of our course for honors. You'll see it. All right, I'll be done with that. I gotta come back. I guess I need to add to my list of examples of finding intervals of convergence. As I recall 2 days ago in class, I only gave you one example. It's clearly not sufficient. I apologize for this. We got to beat that clock. I don't want to make up examples off the top of my head and not survey a variety of answers. So I made some up for class. I know you should make them up on the spot. I just want to be conservative with my time. Here's a series. Question: what is the interval of convergence? I'm kind of hoping you guys at this stage of the game for the last week of class are relaxing. I'm just simply doing something as basic as looking at our tests of convergence. Now personally, this is a power series. So to find the interval of convergence, I typically go back to the ratio test for only this reason. If I use a ratio test, at least I know if the absolute value ratio of a sub n plus 1 to its predecessor is strictly less than 1, I got convergence. That's the reason why I like to use this test in finding intervals of convergence. I know exactly what the radius is going to have to be, or at least I can solve for it. So let's give it a shot. I think the ratio test is the following. When I take a peek at the limit, as n increases that bound, of the ratio of the n plus first term to its predecessor in absolute values, you guys tell me if I'm walking too fast. Would that be this? And I mean it. You be honest with me if I'm walking too fast. What I have within the limit is just the absolute value ratio of a sub n plus 1 to its predecessor. And the ratio test says, if I force this limit to be strictly less than 1, then I can determine the values of x for which I do indeed have convergence for that power series. So if you guys don't mind, since the absolute value of x has nothing to do with n, can I pull it outside the limit? It's all by itself now. And I'm going to take a quick break, if you guys don't mind, and simply evaluate the limit of the garbage in terms of n. And I think in terms of n, actually I have no idea what I get. Do I have the limit as n plays its game of the ratio of 2 times 2 to the n times n factorial over n plus 1 times u finishes off. Lots of cancellation. What is this limit of magnitude? I can't hear you. I can't hear you.
0.
Thank you.
Oh, it's denominator.
For what values of x is that inequality hold? For what values of x is that inequality hold? All. So I think the radius of convergence is...
Or negative infinity to infinity.
Well, the radius of infinity, so the interval, you're right, is negative infinity to infinity. The radius of convergence is equal to this, and the interval of convergence is nothing more than all real numbers. Are you there? If you want some tricks to put in your back pocket, and I don't like memorizing, I don't like remembering anything. But if that's the way you are as a learner, you just say this limit on the outside of x turns out to be 0, your interval of convergence is infinity to infinity. Well, I meant negative infinity to infinity. So far, so good.
So if you got a different answer other than 0, how would it change your?
Oh, don't worry. My next
interval?
example will go illustrate that.
Okay.
That's what I'm saying. Instead of making some examples up and not giving you a nice wide variety, I made some up ahead of time. So I ensured to do that.
Okay.
Oh, you guys, we're doing great with time. I don't have to rush. How about something like this? Actually, to be honest with you guys, this particular series, I didn't make this one up like I did the others. This one is a very special series, power series. It's so special it's got its own name. Oh no.
Bessel function.
You guys, I'm serious. I don't know if I remember how to spell this correctly. His name?
So it's
I
one L.
think it's just one L.
Yeah, it's one L.
Please, I apologize if I'm wrong. So, question. What's the interval convergence? Let's dive in. I think to check my interval convergence, I'm simply going to take the limit as n increase that bound of the absolute value ratio of a sub n plus 1 to its predecessor and force that limit to be strictly less than 1 via the ratio test and just simply solve that inequality for x. That means I have to value the limit along the way, specifically this limit. Is that an x to the 2n plus 1? All over 2 to the 2 times n plus 1 power. Is that n plus 1 twice as a factorial? Dividing out by its predecessor, same thing as multiplying by its reciprocal. Is that just going to give me this? And it's cleanup time so that I can evaluate that limit. Actually, in terms of the x's, since x and 2n cancels, is it not true that on the outside I simply got an x squared? And if you don't mind, I'm pulling it completely outside the limit, so I don't have to worry about it anymore. However, within the limit, I think I've got the following mess. Oh, fraction bar. Okay, I'll slow down. I'm being honest. I don't remember what I get. Upstairs, I get this. Downstairs, I think I get this. I also think I get nifty cancellation. So question, what does that limit of value to? Yeah, I think I get a 0 all over again. So, yes.
So I'm looking at the top x raised to the 2n plus 1.
Gotcha.
Breaking it down, I would get x times the 2n times x squared. Oh, I see the x to 2n.
And so the x to the 2n's cancel, and I was merely left with a factor of x squared. It's just that since there's no more n's in that factor, I pulled it outside the limit. Not that you have to, you don't have to.
So instead of just canceling it totally, you would pull it out for comparison reasons?
Not for comparison reasons, so that I can actually answer the question, what values of x satisfy this inequality down here?
Gotcha.
Well, in this example, maybe a little silly, because my last example is the same answer. My radius is the same, my interval is the same. But it was more complex though. Yes?
I'm confused about what the one means, or the...
Means a lot. Matter of fact, this is why I came in and chose to take the limit of this particular expression, because the ratio test tells me that the limit of this expression, a sub n plus 1 over a sub n, absolute values. If that limit is strictly less than 1, I've got convergence.
Right. So you just throw it in there at the beginning and...
And that's exactly where the one came from. So I'm trying to use that ratio of test to find the value of x for which I do have convergence. Okay, if you guys are still happy,
What was so special about that power series?
actually it pops up in a lot of applications. And I just thought it was a nice one to talk about in class, or one of my early examples, because I think, like Dave was pointing out, you might have to stall for a minute. Say, well, how does everything really split up when I clean up? I thought it was complex enough that it was interesting to do in class.
So is it always the most convenient just to center it around 0 when you're doing these?
No. necessarily. I mean, what if I had y equals the square root of x? And I want to approximate, I don't know, something like the square root of h. Wouldn't it be more interesting to center my power series about x equals 9? Because it's easy. I can take the square root of 9. And maybe through all the differentiation process, I'll do this today, by the way, before we leave. Through the differentiation process, it'd be easier just to deviate from 9 by 1 unit to get an approximation for you.
Yeah.
If I center the power series about x equals 0, gosh, I gotta deviate all the 8 on the horizontal x-axis. And there might be some discrepancy between my power series of the first several terms and the original function.
Yeah, there are a couple I did like that.
And so I think sometimes you want to intelligently choose that value of x about which you're centering your power series, just so your approximation numerically are better.
Okay.
And by the way, before we're done today, I will talk about how off that might be.
Okay.
I'll give me if I should compute that.
Okay.
You guys, how about this one? I know we're almost at a break. Can we just do one more? How about 1 over n? 1 over n, x minus 2 to the n. I'm looking at the sum. Oh, everybody watch. I just made a mistake. I guess with the way I define this power series, I better start n equals positive 1, because at n equals 0, that 0th term doesn't make sense. So, question. For what values of x does this power series converge? For what values of x does it diverge? I think here too. I'll take a peek at the limit as n plays this game. You know, I might be able to get rid of that. It's just that it makes things more complex with the n. And besides that, with the ratio test, this drops out anyways, doesn't it? I think with the ratio test, I just got the absolute value of x minus 2 on the outside. And I have an n over n plus 1 in terms of inside the limit, excuse me. I'll force it to be less than 1. But doesn't that necessarily imply that this limit right here evaluates to positive 1? Oh shoot, look what I just did. Everybody, I transformed this Math 31 question into a your favorite type of question, which is a Math D question. I can solve inequalities involving absolute values in my deep REM sleep. So can you. Oh man, you're killing me.
That's a 1.
And greater than. And so x is sandwiched between. Positive 1 and you said random.
3.
So everybody, what's my radius of convergence?
1 and 3. Or,
It's 2.
2. No.
Would it be 1 to 3?
1. It's that number right there.
Because it's the biggest.
Because at 1, I deviate 1 unit to get to. From the middle, I deviate 1 unit to the left and to the right to get the extremes. I think my integral of convergence is from
1 to 3.
I can hear you.
Negative 1 to 1.
I can hear you.
Nothing.
We have no clue. We have no clue because I don't know what's happening at the endpoints. I gotta take a break, pull out a nifty piece of scratch paper, and on my piece of scratch paper, I need to check my endpoints. And checking my endpoints, you guys, during the break, I promise I'll get a pen. Sorry. I think in checking the endpoints, like for example, positive 1. If x, ooh, that's nice, is equal to positive 1, let's see what happens. I'm going to go back to the very original series. And I think with the original series right here, if I plug 1 in for x, check out what I get. I get the sum of negative 1 to the n over n. Does that converge or diverge? Does that converge or diverge?
Diverges. Or
No.
It converges as the
as n goes to
Alternating series bounces back and forth over. Yeah.
Harmonic series, the alternating harmonic series. Whew, good. And at the other endpoint, if x is equal to positive 3, let's check out what I get. Plugging 3 in for x, I might just get this.
converges.
Converges as, it does it really?
No, that
It
diverges.
diverges as the,
At
okay, or as the
P
har-
is,
Harmonic series.
yeah. Or a p series of p equal to 1, which is not strictly bigger than 1.
that's right.
And so I think we just found out what the interval of convergence is, so that we can take a break. So we can take a break, you can tell me. I know you can.
There is no convergence.
1 to 3. Close parentheses.
Bracket.
1 to 3.
1 to 3.
Cool. Open parentheses.
So close a parenthesis. Because I had divergence at that one extreme, but convergence together.
It's hard and soft.
Okay.
Yeah, I'm saying,
Get that.
you choose a different word, that's fine. Man, silence is still killing me. Is that okay for the first couple examples?